Hello everyone, welcome back to my YouTube channel. Today we are going to talk about very important topics. Those are going to be very much game changer because before building the PD, LGD, EAD models, or I would say even the estimated loss models, you need to know certain things. After processing the data, there are some steps which you need to follow. First is we'll understand how to calculate the default flag, or I would say how to calculate the dependent variable. Now what is dependent variable? Dependent variable is a variable which we are going to predict whether the person is going to default or not, whether the customer is good or bad. So this is our dependent variable which we need to define basis on the independent variable which are there in the data. Again, we are going to understand using Python how we will calculate this. I will give you the data and we'll work on that. Then we will talk about fine classing, coarse classing, weight of evidence. Before going to the model preparation, these are the mandatory steps you should be following in any credit risk model. Now, without wasting your time, let me take you forward. So guys, let's start the discussion. So first of all, after pre-processing, in last session I have covered the pre-processing of distributed variables, whatever it is, like continuous or discrete, whatever type of it is. Okay, so today is going to be more over the focus on the analysis. So let's take the blue pen. Okay, so now when we talk about analysis, so when you go further after your pre-processing of data, the most important thing comes is ECL, or we call it EL. The full form is estimated loss, and also it's called as estimated credit loss. So don't get confused, estimated loss or estimated credit loss, ultimately it's the same thing. Okay, now there is a formula to calculate ECL. So ECL is equal to probability of default multiplied by loss given default multiplied by exposure at default. So this is the formula, I would say equation number 1 for calculating the estimated credit loss. So you should be knowing this, number 1. Okay, now if you want to go for any calculation here, let's say PD, LGD or EAD, I will detail all these topics going forward. Okay, but the primary goal is to understand that what are the component doing to calculate this ultimately. Okay, now the primary thing you will do as a model developer, you will define, number 1, you will give the definition of good and bad customer. What is a good customer? A customer who is not defaulting. A customer who is defaulting is obviously a bad customer. At the same time, it can be called as a bad definition. So that's what we call it. We call it bad definition. Now this bad definition is very tricky. I'll tell you why. Because in real world, if you work for many of the company, let's say if you work for Citi, Bank or Wells Fargo, usually in all these companies the bad definition is already defined, which is 90 plus DPD. Let me highlight it. Now you will obviously ask me, Rajat, what is the meaning of DPD? What is bad definition? Bad definition tells you what is a bad customer. How you will identify the customer is bad? Obviously the bad definition will tell it, right? So bad definition is the definition which tells you that on the basis of the historical data, these are the people who are the bad customer. Now generally the people who are not paying their EMI, for example, from last 3 months, that is a bad customer. Now how this 90 plus DPD works? DPD means days past due. Now DPD concept is very important. You should know this. How it works is, first of all, if anybody default the EMI, so obviously 1 month, that is known as 30 plus DPD. If I'm not paying my EMI for 1 month, then I'm not paying for 2 months, so that's called 60 plus DPD. I'll tell you why I'm writing this. Then third is, if I am not paying my EMI on the 3rd month also, this is known as 90 plus DPD. Now in banks there are bucket for all these 3. Bank will get to know, let's say I have total 100 customer in a credit card portfolio. These 100 customers are in Bangalore, they are using my credit card. Let's say how many of them are 30 plus DPD? Let's say maybe 5, not more than 5. It's very rare percentage, okay? Maybe 5 people have not my EMI on the first month. Then 2 of them paid the EMI on the second month, so now it's 3. At the end of the second month, I have 3 people who are 60 plus DPD. Now these 3, one of more member is paying the EMI on the third month. Now only 2 people left. So these 2 people is your bad customer. You give the customer a chance to pay the EMI, obviously. That's why you give them 2 chance, first month, second month, then third month. If they are not paying, that is a bad customer. That's how usually in credit risk in all the banks, US, Australia, New Zealand, they usually call 90 plus DPD as a bad definition. But in some of the model, you need to calculate bad definition for small bank. But I'll tell you the way also how to calculate the bad definition, but not today's video because that will be too much clumsy for you. But you focus that bank will give you or your business team will give you a bad definition, that how to define the bad definition. Okay. So now in our case, 90 plus DPD is the bad definition. That is number 1. Okay. Now there would be 2 outcome. Either the customer will default or customer will not default. So I told you at the starting of the video, the second step we would be performing is what? Calculating dependent variable, or ultimately we can call it target variable. Target variable. Why we call it a target variable or a dependent variable? Because obviously we have a target to predict for the bank whether the people are defaulting or not. That's why it's called a default indicator. Sometime there are so many names for this. Don't get confused. Dependent variable, target variable, default indicator, everything is same. Now let's say the name of the variable, I call it default flag. I'm telling you on the basis of real life example. After my 13 years of experience, in 90% of the company they will call it default flag. So you need to calculate the default flag. Okay. Now basis on the independent variables. Now what are independent variables? All the data which is given to you by the bank, let's say their personal data, address, PIN code, mobile number, then their professional data, maybe company name, salary, years of employment, then their macroeconomic factor, economic basically. For example, which country they belong to, which state they belong to, which area they belong to, all of that. And obviously every country have a different rating. So some of the countries are very safe. Let's say for example, if you are working in Germany, so Germany has a very good credit rating and mostly people are prosperous. But if you are working at the same time in Afghanistan, you cannot compare Afghanistan with Germany on the basis of that. Okay, so I don't want to demean the country. That's what the banking system looks at. That's how they divide. Okay, so now macroeconomic factor, and these so many variables will be there. Like maybe if you calculate it, it will be around 150 variable, which are like age, marriage status, years of experience, salary brackets, debt to earning ratio. All these common variables will be there. Okay, so you should know that. Now on the basis of these independent variable, you will be defining a dependent variable, which is the ultimate objective of your model, to get to know whether default is happening or not. So this is one. Now on this note, I will take you towards the Jupyter Notebook and let me have a look at it. Now all of you can see I am at the Jupyter Notebook. I have this piece of code, okay, which I have already prepared for all of you. I'll make you understand what I am trying to do here. Let me zoom it. So first of all, going into this code, I hope you remember the previous video before this. I have given a GitHub link. So data is there. Okay. The loan data, which I am using here, it's there already, but I will give you a link in this description box video also. So ultimately you can go to the description and you can download this data. Also, you will get this code. So you just need to change the location and you can run this. Okay. Now why I am writing this code? Before that, let me go to the data. This is my desktop and let's say date modify loan data. I'll click on this. So guys, this is the data. You can see so many columns. Let me zoom it. Member ID, loan amount, funded amount, term of the loan, what is the term of total loan, okay, initial interest rate, installment, what is the installment of the person, grade of the person. So this is not just bank data, this is given by the credit rating agencies also. So bank combined all the data before building the model. So you can see so many columns are here: subgrade, employment title, employment length. Some people are working in company for more than 10 years, some are working for 1 year, 3 years, whatever it is, okay. Now some have rented house, some have own house. Obviously there is a chance that the people who are owning own house, they will not default. So rented people will have obviously a rent liability, so obviously there is a chance of default. So all these factors count, guys. Now annual income, then so many other things, loan status, payment, and their purpose of loan, title, zip code, everything I said. You can see all these macroeconomic, age related, income related, all these factor. Last 6 months detail, so many columns are there. Total payment, how much they have already paid or not, okay. Now collection reports, any recovery pending, all of that will be there. There are so many variables will be there. I'll not go into detail, okay, because if I explain you each and every variable, you will be really bored, okay. So now you just download this file. Now you got the understanding. This is the loan data which is we are going to prepare, okay. Now let's go back to the area where we are interested. This is the Python code. Simply open your Jupyter Notebook. Now in Jupyter Notebook, if you see here, first step I'm doing, I hope the font is good. Let me zoom it more. I hope it's not much. This is fine, I think. I hope this will help. Okay. Now, guys, just look at it. First, I am just importing pandas library, which is the most important part. Don't forget to import. Now, this is the place where you need to do the change. This is my path. Okay. I'm putting it on my desktop. That's why it's able to pull the data from there. You put it your path. Now, I'm putting, let me go down. Yeah, I'm putting a try block, load the data set from the specific path, because I want to create a data frame. What is a data frame? Data frame is a collection of rows and columns. That's what we call in the term of pandas Python. That's what we call data frame. Create new binary column, default flag. I said it's a dummy variable which we are going to create as a model developer. So that's what I am doing. Just create a variable default, and then I am using some lambda function with apply. It's very easy, okay. So don't go into much of the coding. I think you should avoid the coding as much as can. Like I don't want you to motivate to avoid the coding. My point is that try to compress the code so that it's easy to debug. Some people try to make very lengthy code. They like it. I don't like that. Now, quickly, if you see here, so default is the ultimate column, which is your dependent variable, which we were just talking about. Okay. Now, loan status I would be using, and then I'm applying lambda x equal to 1 if x in any of these buckets, charge off, default, late or late. Okay. Now let me explain all this. Charge off means what? After 90 plus days DPD, when the bank think that the customer is not able to pay the amount, so they will give a charge off option to the customer, that we can give you a leverage, okay, basically. So you should not be paying if somebody is bankrupted. That's called charge off. At the same time, default means if a customer status is default, that customer is intentionally defaulting, but they can pay the amount, that is default. Now late by this particular 30 to 120 days means 1 month to 4 month people who are basically late. So all this they are counting as a default flag. Then late 60 to 30 days. So in this particular example, I am calculating 16 to 30 also as a default. But obviously this is my default definition. That's what your company, your business team will give you when you will join as a model developer. So they will give you this default definition. Sometimes you have to calculate. I will tell you in further videos how you calculate. There is a process for that. Now, print the column for default as 1. Whenever there is a default, make this column as an indicator 1. When there is a no default, just calculate all those value and put 0 in front of that. So you will get to know how many 0, how many 1 are there. Now, print default variable distribution. What is the distribution of this new created default variable? Value count I'm taking here. Then print how many loans fall into each particular category. So that will be printed again. Now I'm putting a error exception, I mean to say I'm putting an exception. It will print you to help message if the file path sometime is incorrect. For me it was showing the error eventually because there was a spelling mistake. So for you also it can happen, so put this as an exception in your production code also. I've experienced it. Usually junior programmer or junior model developer, they do this kind of mistake. That's why I'm putting this. So make sure a habit that you put a exception for the file path. Once you will be experienced, you remove this, no problem, you can remove all this part. Okay, but this is putting an exception. So file not found will be printed, so you'll get to know there is a something wrong I have given in the file path. Now simply I'm printing the new data frame which I am creating and the values of that. Now if I click on this whole cell in a single shift enter, so it's giving some messages, that's okay. Now you can see here, okay, this is the output I wanted to see. So it has given all the distribution, guys. That's how you are able to define your dependent variable. That's what we were discussing at the starting of the video. Okay, so default, what was default, 1 or 0? 1, not 0. So how many people are not defaulting? There is a huge count, 2,37,000 are not defaulting, but there are 5 people who are default. So this is our dependent variable, target variable, or default indicator, whatever you call it. Then let's go to loan status distribution. I'm giving loan status also. There are some specific loan status like fully paid, charge off, current. There would be more in real life. It can be write off. It can be any other DPD buckets they can create. So you try to understand there are two most important things are fully paid and charge off and write off. Write off also happens when bank think that the person is not able to pay the amount at all. So bank write off that amount. They basically forget there was a money around this person and they mention in their books that this amount is being written off. They put it in an operational loss so that they can show it to the regulatory that this much amount we have lost this particular year. So understand the model. If you have any question, please do comment, I reply to that. Okay, now loan status I have explained it to you. Fully paid we have 10, then charge off we have 5, and then we have current which is 2, but the overall default indicator is showing there are 5 customers who have defaulted. I hope this is clear to you. This code you will get to download from the GitHub account very easily. I always do that. Okay, and now let's move on again to some very much important conceptual part which you should know, which is fine classing, coarse classing. What are they? So let's go back. So I'll try to be quick. I don't want to make a very lengthy video for all of you to make you guys bored basically. Okay, now there are 3 things: weight of evidence, then you have fine classing, and then you have coarse classing. Just try to understand what is the use of this after creating the dependent and independent variable, because there are some variable shuffling. Sometimes you create categorical variable into continuous variable. Sometimes you create some bins also. You'll understand all this terminology slowly. Don't worry on that. Okay. So first let's talk about fine classing because it's the easiest one. Let me take blue color. Yep. Now what is fine classing? It's a process to create continuous variable. In short, I will write, when you want to convert continuous variable into what? Categorical variable. I'll give you example, don't worry. Categorical variable. This is known as fine classing. What is weight of evidence? Up to what extent a variable have a predictable power. Okay. What extent a independent variable can predict dependent variable. So that dependable probability, or not probability is not the right word, I would say The power of an independent variable to predict the dependent variable is known as weight of evidence. Every variable have a different predictability power, that is known as weight of evidence. So in layman language, we have heard in court, judge usually ask what is the evidence. So every evidence have a weight. So similarly, you can understand here also. Now, what is coarse classing? So when you create new categorical variable based on existing one, this is known as coarse classing. Now let me give you example quickly. I think coarse classing is getting hide behind me. I should not do that. Okay, now let's talk one by one. I think heading should be visible. Yes. Now, fine classing example is, let's say, your debt to earning. So every person have a earning, let's say, then they have some debt. So obviously their earning is increasing, debt may be decreasing, right? At the same time you take a loan, so now your debt and earning both are increasing. So obviously your earning was like 10k, then you have 100k, then you have 300k. So obviously what company do, you are not the only one in the system, there are millions of customers. So company will do, they will create buckets, let's say 10,000 to 20,000 in a single bucket, 20 to 50 in a single bucket, 50 to 100 in a single bucket. So that's what you are doing. So you are creating a categorical variable from a continuously increasing variable. That's what called as fine classing. Number one. Now weight of evidence. For weight of evidence, I'll give you an example of, again, salary to understand it. Okay, so let's say we have a salary. So there are two type of salary. Let's say people with high salary and then people with low salary. Oops, let me remove all this. Yes, so this is high and then you have low. So I'm creating a table here, and then you have good definitions, then you have bad customer, then you have proportion. This table is not going good here. Let me remove some of this part. I think this is clear to you. Let me remove this so that I can make the table much more good. Yes. So now this is proportion of good, then proportion of bad, then in the last you will calculate weight of evidence. This is going to be your table. Then high salary brackets and low salary brackets. This is total. Okay, now how many good? Let's say I say 4,000. Bad will be around, let's say, 600. Now what is the proportion of bad and good if you see here? So let's say 25%, and then proportion is 15%. At the same time, let me give you the low also. Okay, low salary. So let's say 12,000. More people will have a low salary and lesser people will have a higher salary. That's how the company function. This is 25. Then you have, this is proportion of good is 75%. Proportion of bad is here, let's say 85%. Now how you calculate weight of evidence? So weight of evidence is equal to natural log of good divided by bad. So now how you'll do that? 25% divided by 15%. So that will come close to 0.5. Then if you do here also, this will come minus 0.13. That's how you calculate the weight of evidence. The more higher the weight of evidence is, the more good variable it is for your model. So this is weight of evidence. I hope this is again clear. Now let's talk about coarse classing. Okay, so let's say I created salary variables. I told you, let's say 10k to 20k is 1, then 20k to 50k is 2. Now I want to combine these two. So basically what I'll do, I'll create a new one, 10k to 50k. Depending on the relevancy. So what I'm doing, I'm creating a new categorical variable using the older categorical variable. Okay, now on that note, I would like to conclude this video today, and I hope this was much more clear to you. Very soon we are going to head towards the PDLD, LGD, EAD, all these concepts in terms of actually implementing it. So I hope this was all clear to you. If so, on that note, I would like to conclude this video. I'll see you in the next lecture, and we'll make a good progress on understanding this credit loss completely. If you have any question, please put your question or comment in the comment section. Make sure you subscribe to my channel, and please share this video with your friends and your family. Thank you so much. I'll see you in the next video. All the best, guys.